Hello friends, in this video I am discussing about transportation or distribution method of solving linear programming problems aims at minimizing cost of material handling, sending goods from dispatch to receiving ends. Generally, specific quantities of goods are shipped from several dispatch stations to a number of receiving centers. Linear programming approach in such situation tends to find how many goods may be transported from which dispatch station to which receiving end in order to make the shipment most economical. Transportation technique in such problem gives a feasible solution which is improved in a number of subsequent steps till the optimum feasible solution is arrived. Three methods for solving transportation problem, and these are least cost method, northwest corner method, and Vogel's approximate method. Now in this problem I am solving this problem by using least cost method. Here you can see that there are three factories F1, F2 and F3. These are supplying the goods, and four stores S1, S2, S3 and S4. These are receiving the goods. Now the demand for store 1, 2, 3 and 4 is 20, 30, 50 and 50 respectively. The supply by factory 1, factory 2 and factory 3 is 40, 60 and 50 respectively. Here you can see that the total demand is equal to total supply. Each one of them equal to 150. Now in list cost method, first of all we have to choose the list value. Here you can see that the list value of cost of transportation is 4 when we go from factory 1 to store 1. So the list value is 4, so we choose 4 here. Again, now we have to think here like that factory 1 can supply maximum of 40 goods, but the demand at store 1 is only 20. So we fill here 20. Now the remaining at factory 1 is 20 goods only, and that at store 1 there is no demand, so we have to cut the supply from factory 2 and factory 3. There is no need of supply. Store 1 demand is fulfilled. Now we have to select the next list cost of transportation, and here it is 6. But the interesting thing here is there is 3 number of 6. Okay, so we have to select here that store which have maximum demand. Here store 3 has maximum demand of 50, so we select store 3 before selecting the store 2. So we select store 3 here, and again there is a tie between factory 2 and factory 3. Factory 2 can supply 60 goods, whereas factory 3 can supply only 50 goods. So here we choose factory 2 because it can supply more goods than supply. So store 3 need of goods is 50 only, so we fill here 50 and cut 60 from factory 2. The remaining goods is only 10. Now we see that the demand of store 3 is also fulfilled, so cut the supply from factory 1 and factory 3. Again there is another 6 for store 2. Now the demand at store 2 is 30, whereas the supply from factory 1 to store 2 can only be 20. So we fill here 20 only, cut here, and there is 10 more demand remaining at store 2. But factory 1 now cannot supply any goods, so we cut the cost 8, which is from factory 1 to store 4. We cannot supply. Now there are four cost value remaining, 2 are 8 and 2 are 7. So the next list value is 7, and there is again a tie, but we have to choose that store which have maximum demand. So here the maximum demand is 50 for store 4. So we feel only 10 here because factory 2 can supply only 10 goods. So the remaining demand is 40 at store 4, and the remaining demand at store 2 is 10, and there is only factory 3 left which can supply, and factory 3 can supply 50 goods. So we divide 50 into these two store. Store 2 get only 10 and store 4 get the remaining 40. Now our all goods are supplied from factories 1, 2, 3 to store 1, 2, 3 and 4 at the list value of cost, and the list total cost is simply 4 into 20 from supplying goods from F1 to S1, 6 into 20 from supplying from F1 to S2, 6 into 50 from supplying goods from F2 to S3, and next is 7 into 10 from supplying goods from F2 to S4, and the next one is 7 into 10 from supplying goods from F3 to S2, and the last one is 8 into 40 for supplying goods from F3 to S4. Now by calculation we get the total value of cost is 960. So this is the least cost method of transportation problem. In the next video I am solving this same problem by using northwest corner method. Thank you for watching.